Want to welcome everyone and welcome Jennifer Skulski to our forum today.
Thanks, Renee. Hello, everyone. I'm here in central Indiana, where we have a beautiful blue sky, great day to be outside on the trail. So for those of you that are inside like me, we're going to talk about accessible exterior surfaces. This is the second part in this series. So just let's go over a little bit of a refresher about part one in case you missed it or want to go back and follow up on a couple items. So we talked about the accessibility standards. And so generally when we specify accessibility standards, we're looking to the 2010 ADA standards for accessible design. That's part of the Americans with Disabilities Act. Those were updated in 2010. Unfortunately, those standards do not include outdoor developed areas like trails, campgrounds, scenic viewing areas, or beaches or picnic areas. So, because that's not part of the ADA standards yet, there are standards in the Architectural Barriers Act covering those outdoor developed areas. And the Architectural Barriers Act applies to the federally conducted and federally assisted programs. So federal land management agencies like the National Park Service, the Forest Service, U.S. Fish and Wildlife would follow the Architectural Barriers Act accessibility standards. Since we don't have outdoor developed areas under the ADA yet, we can look to that chapter in the Architectural Barriers Act as the best available information or guidance for those of you that manage units of state or local government, like your local park districts, park and recreation departments, greenways and trails, so forth. So we also have new developments under both the ADA and ABA that includes accessibility guidelines for public rights of way. Those standards have been adopted by the U.S. Department of Transportation. So if you're receiving any type of federal highway dollars and working in the public right of way, you would need to follow those guidelines. And then anything outside of that, we're still waiting for the Department of Justice to adopt it into the ADA itself. In addition, we have the International Building Code has an accessibility chapter within it. It's part of the A117, Accessible and Usable Buildings and Facilities Committee. It's part of their work. And so their work runs on a 3 to 5 year cycle and actually just issued an update for 2024, and we'll have another final update for 2026, and then we'll start the cycle all over again. And that International Building Code is often adopted by your state and local code. So you want to make sure and reference your state and local code, of which Minnesota actually follows the International Building Code and the A117. And you actually have parts of your Minnesota building code, the accessibility standard, that are actually more stringent than the Americans with Disabilities Act accessibility standards. So look to all of those documents. And this kind of points out what we're looking at in terms of guidance material. So Chapter 10 under the Architectural Barriers Act and the Americans with Disabilities Act accessibility standards, that covers recreation facilities for both of those. Outdoor developed areas is included in the Architectural Barriers Act, but not yet in the ADA. Public rights of way is now in both the ADA and the Architectural Barriers Act. And then within public rights of way, there is a very, very brief clause about shared use paths. So in part one, we talked about unique paths, those including accessible routes, outdoor recreation access routes, trails, beach access routes, pedestrian access routes, shared use paths, and pedestrian circulation paths. So we're not going to really talk about the definitions or discuss the technical provisions, but I would refer you back to the part one webinar for a more detailed discussion on each of those and how they're unique from each other. Just to kind of give you a very brief description of how they are different, you do need to know the definition of each of those because they do each have different technical provisions. So the accessible route, that's considered most often in the built environment, that's going to have the most stringent technical provisions. So the maximum slope for an accessible route is 5%. You can do that forever in terms of the length of the segment. But anytime you're over 5% and all the way up to a maximum of 8.33%, you are required to have handrails and landings because that accessible route, in fact, turns into a ramp. And your maximum length for each segment would not exceed 30 feet. In outdoor recreation access routes and trails, it gives you a little bit more flexibility. The handrail requirement is removed. It lets you go up to 8.33% on a trail for 200 feet without having any type of landing. You could go up to 10% for 30 feet on a trail, or all the way up to 12% for 10 feet on a trail. And you could do that as many times as you wanted to before you would actually have to have a landing or a resting interval. And then there's additional technical provisions for the beach access route, golf access route within the playground, and the pedestrian access route is actually considered part of the shared use path. And so the shared use path, your pedestrian access route within that footprint of the shared use path has to be the entirety of the width, and it should not exceed 5% within the right of way, or the grade, if it's within the right of way, it cannot exceed the established grade of the adjacent street. And you can do that for as long as you need to. There's no specificity on the maximum length of the segment. So I've also included a chart here about those different types of paths, those that are most often used in the outdoors: the accessible route, the outdoor recreation access route, the trail, and the pedestrian access route that could either be part of your sidewalk in your public right-of-way or part of the shared use path. And so you're welcome to use that for your convenience. So other components of the accessible route, the technical provisions also include requirements for the floor or ground surfaces, changes in level, turning space, clear floor space or ground space, accessible routes, the walking surfaces, and then there's more specifications at doorways, ramps and curb ramps, elevators, and platforms. And we're going to talk about a couple of these. So within the requirement for the floor and ground surfaces, section 302, this is the part of the standards that has doesn't actually have an objective measurement to it. It requires that your accessible surface is firm, stable, and slip resistant. It's the only part of the accessibility standards that is really subjective. It's left to your best professional judgment, so to speak. But when we talk about firmness and stability, the access board defines those as a stable surface is one that remains unchanged by contaminants or applied force. So when the contaminant or force is removed, the surface returns to its original condition. And a firm surface resists the deformation by either indentations or particles moving on its surface. And then a slip-resistant surface provides sufficient frictional counterforce to the forces exerted in walking or permanent safe ambulation. So really, and I'm going to talk more about this in a couple of minutes, those are very subjective. They're left open to interpretation. We don't have an accepted way to measure each of those in order to determine if the floor or ground surface is accessible and compliant with the accessibility standards. So other requirements for the floor and ground surfaces. If you have openings in the surface, that opening cannot exceed 1/2 of an inch in diameter. If you do have openings, they can be elongated, but the dimension has to be perpendicular to the path of travel, or I'm sorry, to the direction of travel. There's also requirements for carpet. So the maximum pile height is a half of an inch. The carpet has to be secured. It has to be firm. Preferably, it does not have a cushy pad or cushy cushion. The exposed edges should be treated so it doesn't roll up. And also recognize that this requirement for carpet also applies to sports turfs, either synthetic or what is considered synthetic or artificial turf. So if you're using that on the playground or an outdoor play area or as part of the accessible route to a sports field, that part of the accessible route has to comply with the carpet pile height requirement. And then changes in level for our floor and ground surfaces. You can have a change in level up to a half of an inch. Up to a quarter of an inch, it doesn't have to be treated. At a quarter of an inch, that's your maximum vertical. But anything over a quarter of an inch up to a half of an inch has to actually be beveled. And so you'll see some of the issues where we have two different types of surfaces meet each other, and it creates a change in level, which can be an issue for people ambulating across the surface. Our maximum walking slope on the accessible route is 1 in 20, or what is roughly 5% for the running slope. And our cross slope is 1 in 48, or what is roughly 1.08%. Oftentimes you'll hear from people that use manual wheelchairs where the cross slope is too steep. They have to overcompensate on one side, and the cross slope can actually create more challenges getting across the cross slope than it would a running slope. So we want to maintain or shoot under that 1 in 48 or that 2%. So other requirements for ground surfaces, you're working with playgrounds, there's ASTM requirements for impact attenuation and the safety specification around the equipment. And then there's also an accessibility standard within ASTM for that area that is used as part of the accessible route that is under or around the play equipment. That's the ASTM 1951. So some considerations for exterior surfaces. And I want to point out too that there's a lot of pros and cons, and I've been working in this area for more than 25 years and looking at all different types of surfaces. And I can easily say that based on that experience, there is no perfect accessible surface. They all have different pros and cons. You really need to look at what do you have, what are the resources available to you? Do you have more capital dollars for a surface that likely is more costly, but probably doesn't require as much maintenance? Or do you have those maintenance dollars available to you, but maybe not as much capital dollars, that you choose a surface that might not be as much upfront to purchase and install, but might take more maintenance than some of your traditional unitary surfaces. But down in the lower right-hand corner, some of you may know Bill Botten. He was at the Access Board for almost 30 years. He and I have worked closely together over that time period. We really started looking at this issue back in 2004. When they're on the market, we started to see an influx of surfaces, and it really had to do a lot with playground surfaces, that we would see marketing materials claiming that the surface was ADA approved. Well, there's no such thing under the ADA as ADA approved or ADA certified. And so we ended up going out to an ASTM meeting. And as part of that meeting, a group of us following the meeting went out to a couple of playgrounds in the Denver area that had this shredded rubber surface. And this is a picture of Bill using his manual wheelchair to go through that surface, automatically just, stepping into it or wheeling into the surface. Automatically, the wheelchair would just sink into the surface. It was very difficult to wheel across. And kind of as a side note, within probably an hour, we were all out at both playgrounds, maybe for 2 hours tops, and then when ended up going out to dinner. We had two wheelchair users with us, Bill and one of our other colleagues, Peter Axelson. Within that hour period of sitting in a restaurant, they both had flat tires from the shredded rubber had medical particles in it that ended up puncturing their tires on their wheelchair. And literally at this nice restaurant, they're both taking the wheels off their wheelchair and reinflating the tubes or putting new tubes in so that they could use their wheelchairs for the rest of the night. So that was pretty much our tipping point to say we really need to look at these different types of surfaces and figure out what's accessible, what are the pros and cons for each of those in order to give the facility owners more information to make an informed decision about what's most appropriate for their site. So we've divided the categories of surfaces into two, one being loose fill materials and the other one being unitary surfaces. And so I've listed the whole gamut of exterior surfaces. Just because it's listed here does not necessarily mean it's accessible. So for a loose fill material, you could have sand, gravel, crushed aggregate, brick dust, decomposed granite or fines or crusher fines. You could have wood chips or wood mulch or engineered wood fiber or even the shredded rubber. Those are the different types of loose fill materials. And then for unitary surfaces, that could include everything from concrete to asphalt, bricks and pavers, wood planks, plastic lumber, snow fencing, geosynthetics or textiles, the synthetic turf, the different types of web cells or grids, poured in place rubber and tiles, and then the application of different binders or soil stabilizers to stabilize a loose fill material. So when we break those two categories down and look at the different advantages and disadvantages, when we look at unitary surfaces, the advantages generally are that unitary surfaces can provide an accessible condition that is more consistent and predictable than the loose fill. That's probably the primary draw to using a unitary surface material. Generally, the unitary surface material has a longer life cycle than loose fill. It requires less frequency of maintenance, and it can also convey a higher end aesthetic to the environment. The disadvantages are that, automatically that strikes it off the list is that generally unitary surfaces are much more expensive than loose fill. Your bottom end of your loose fill materials are probably about $1 a square foot or even less, where the start of your unitary materials, you're looking at 10, 14, 15, $16 a square foot, just at the bottom of the range for unitary surfaces. So they're much more expensive than loose fill. They usually require more intensive installation. They might even require a skill set of labor. Some of the surface materials require the installer to be certified with a product manufacturer. They also might require maintenance or corrective actions that can be more costly because they require that skilled set of labor to fix any deficiency in the surface. When it comes to the loose fill materials, some of the advantages, obviously, that it's much cheaper than the unitary surfaces. It's usually easier to install than unitary surfaces. It doesn't generally require a special skill or certification. Some of the materials are more readily available based on where you are geographically. Like I'm in central Indiana, it's the limestone capital of the world. So the crushed limestone cost to me is probably much cheaper than it would be for you in Minnesota, or based on where that hull difference is to bring in the material. And then there are certain loose fill materials that are more supportive to drainage and stormwater runoff than unitary surfaces. Some of the disadvantages, obviously, again, the loose fill material requires much more maintenance to maintain it as an accessible and safe surface. The loose fill material can become more difficult to walk or wheel across. It can be easily displaced outside of the containment area. It might be prone to erosion. It can wear faster based on the weather exposure. And in some instances, it could be more flammable or subject to vandalism. And the loose fill materials can conceal trash or foreign objects easily. So some examples as applied out in the field, concrete and stamped concrete. This is what we see a lot in terms of the outside or exterior environment. The use of concrete, stamped concrete, the technology for stamped concrete has improved tremendously. So this is definitely an option to look to, especially for your primary paths of travel. Other options might be considered asphalt and asphalt millings. We see a lot of park settings that use asphalt. We're seeing a growing number that are using asphalt millings that are coming from highways. I would actually note on here that the asphalt milling, depending on how it's installed, may not necessarily be a firm and stable surface. It probably requires additional compaction, doing some roller compacting. It might actually even require some type of binding surface in order to be firm and stable. Wood boards could be another option. Both the combination of the wood boards or the plastic composites, and then pavers. And I kind of joke when I see well, I don't really joke. I get anxiety when I see these two pictures. Pavers, we see that a lot of times used in the outdoor environment, but that the roughness of the surface can create issues for people with mobility impairments. The changes in level can also be a challenge as well. Poured in place rubber and rubber tiles, those might be things that you look to, especially in the playground or a splash pad environment, where you would have that poured in place, rolled out rubber or the interlocking rubber tiles. And then options with the synthetic turf. We're seeing this in outdoor kind of lounging areas where, you might have an urban center that uses the turf to provide a little picnic area in addition to maybe cornhole or big outdoor games. And then, of course, with different sports fields and play areas. And then we do see a couple hybrid surfaces. When we talk about hybrid surfaces, those are both loose fill and unitary surfaces. This one is called the Smarty surface. This is actually the base is shredded rubber that is put into 24 by 24 inch pillows. So that's the subsurface. And then there's a top mat placed on top of it as a unitary surface system. And so it functions for both accessibility and safety in different types of outdoor environments, but it was primarily designed for the use in playgrounds. And then engineered wood fibers. So I want to make sure that people understand that there's a difference between wood mulch and what we now call engineered wood fiber. So wood chips or wood mulch, that would be something that you just put through the chipper. It's the same that you would be using in your landscape beds. But early on, one of our earliest ADA complaints that went to the Department of Justice and then was investigated at the Department of Interior was against a city that had installed that wood mulch, where the Department of Interior Office of Civil Rights found that that wood mulch was not accessible. And so after that complaint, the playground industry that sells engineered wood fiber actually went to ASTM and created a standard for engineered wood fiber. And engineered wood fiber is meant to knit together. So it does more than just going through a chipper. It goes through multiple processes between a chipper and a compaction or a pressing process to flatten out the wood chip and to make it so that it would knit together. And so that's its primary difference. And then the ASTM standard actually has requirements for the sieve size and the percentage of the sample that has to meet the requirements for certain types of sizes of the sieve. Then other options for outdoor surfacing, decomposed granite. We see this being used a lot in the Rocky Mountain area that because that surface is more readily available. And then, as I mentioned before, here in Indiana, we see crushed limestone used a lot as well. Our perfect recipe here in Indiana for crushed limestone is a 50-50 mix. It's a mix of stone, 50% stone, where the stone size is a 1/4 inch or smaller. That's 1/4 inch or smaller, 50% mixed with 50% dust, and then installed, wetted, and compacted and wetted. And then over time, it will set up just as hard as concrete. It's a really nice trail surface. There's a lot of use of it in the Midwest with the National Park Service. And then after, depending on your use, every so many years, you'll probably have to go back and do a top dressing with more dust because eventually the dust will settle and you'll need to replenish the dust and then compact and wet that. In the coastal areas, we see a lot of use of crushed shell and marl, same type of situation, looking at the particle size and making sure that those are crushed enough to provide a firm, stable surface. And then the use of soil stabilizers, this one in particular, this is from our friends at Kafka Granite in Wisconsin, that they use, they look at a lot of different applications for the use of decomposed granite. So they've actually come up with a really cool wax coating system that the particles are coated in wax and then they're laid out and compressed, and the wax kind of knits together and provides a soil stabilization. And so it's a very, very cool product. It's a lot more than some of the loose fills, but depending on the aesthetic that you're going for, it might be a consideration that you want to use maybe in an outdoor garden or conservatory. Or in this particular application, there was a ADA complaint against Rutgers University golf course where the Department of Education found that a part of the path system for the golf. So the university golf course staff worked with Kafka Granite to install this product, and it ended up meeting the requirements of the Office of Civil Rights for the Department of Education to settle that ADA related complaint. And then another type of soil stabilizer, there's another one out there called EnviroSeal. This has been out for a long time. It's an on-site application where EnviroSeal, the way that it started out was in the first Iraq wars. It was used by the military to spray down the sandy surface in order to stabilize the sand for use for helicopters to land in that desert type of environment. And then the use of the product really expanded to other outdoor applications and primarily trail use. And so this is one where EnviroSeal, they will encourage you to send a sample of your different soil that you want to use the stabilizer with, and then they will test the different recipe in their laboratory setting and come back with their recommended concentration of how you should apply the product. So that might be another option if you're looking for something that is more of a natural aesthetic. Another area that we're seeing really evolve over the last 20 years is the different types of beach mats and path systems where you can apply a temporary mat type setting in order to provide a unitary surface. This example from Access Recreation, they have a number of different types of paths that are primarily for beach mat use, and then they actually are now branching out to park uses as well. So if you have some type of temporary event or festival, you can roll out a path that has been designed for use over grass, or even at a dog park or in a natural play area, you could use that type of temporary mat system. So some of the examples of the common deficiencies that we see with these different surfaces when we're conducting accessibility assessments as part of the ADA transition plan. Many times we'll see an excessive running slope or cross slope. So that means that the surface has been installed, but the way that it was installed or the way that it's been top dressed or maintained exceeds the maximum allowable either slope or cross slope. We also, the changes in level, this is probably the number one thing that I write up when it comes to accessibility assessments in parks and recreation areas. We especially see changes in level where two different surfaces meet each other. So generally we see it where you have a unitary surface meets up with a loose fill material, and the loose fill material starts to settle and it creates that change in level that is more than that 1/2 of an inch and it's not beveled. So we really need to pay attention to those, especially if they're part of the accessible route, and plan for our maintenance to, one, bevel that edge and have that seasonal top dressing of the loose film material so that we can maintain the accessible route. And then the other issue that we see with changes in level is expansion joints. I mean, I'm in the Midwest, you're in an area as well where there's a lot of freeze thaw, that what was originally as installed as an accessible unitary surface like concrete, after a couple of years of high intense freeze thaws, all of a sudden we have changes in level at the expansion joints. And I kind of laugh a little bit when I see this picture at the drinking fountain where the expansion joints have been marked with orange spray paint. And we were riding up this park, and I just mentioned to park staff, well, hey, you have some changes in level here, but that's great that you've marked them off and that you're going to be fixing them. And the staff replied, well, don't be that impressed because we painted them probably about 7 or 8 years ago. We just haven't gotten to them on our list of corrective actions yet. So, we had our little chuckle, but it's definitely an issue to take into consideration because that backlog of maintenance can, really build up fast and really put your maintenance and operations budgets behind the 8 ball if you're not able to chip away at those every season. The other issue in changes in level on asphalt, where we see asphalt heaves, same type of thing with the expansion joints, is that what was originally installed as a nice unitary surface used for this trail or greenway system over a couple seasons of freeze thaw has now heaved. And so one of the resources that we recommend people look to, especially when they have a lot of surface area or a lot of trails or greenways that use asphalt, in trying to figure out which surfaces do we make corrective actions to first, or what do we resurface first, is that there's a phaser system that the highway people use. It's the pavement surface evaluation and rating system. You can get it online, but basically it looks at like a 10-foot section of path, and it makes you count the heaves or the cracks and rate the decay of the surface. And that rating system can help you determine what are the segments of path that need to be either resurfaced or repaired. And it helps you with a prioritization and scheduling for those corrective actions. So other issues with the pavers and changes in level, another area, again, that this could be installed perfectly level and accessible in a couple seasons of freeze thaw, and you've got this settling. And I will tell you from our experience doing the accessibility assessments that the cost to pull up an entire section of pavers that has been installed, I don't know, 7 to 10 years, to pull it up, level the subsurface, and reinstall the pavers that have settled or have all these changes in level. The cost to do that, to re-level that, is almost as much as the original cost to install it. So if you're dead set on using pavers, you really have to plan for every 7 to 10 years that you're going to go in, pull them all out, level them, and reinstall them. There's just no way to, especially where we have these areas of freeze thaw and water getting in there and affecting how the surface lays, that we have to maintain them. Other areas, again, where you have two surfaces meeting each other and that settling or buckling. And oftentimes with these kind of changes in level, we will see the complaints arise out of safety issues much quicker than they do out of accessibility. You're much more likely to have somebody fall and trip and maybe file a lawsuit against you that way versus it being an accessibility or an ADA complaint. So just something to think about there too in terms of, can you tell that I'm not a fan of papers? I like the crush or the stamped concrete. So other issues, slate pavers, this can be an issue as well. While it might be really cool for the aesthetic, especially in a conservatory or an outdoor garden, those openings in the surface create changes in level as well. And so we really need to look at maintaining that accessible route and minimizing the opening size. We see these grid pavers used a lot in outdoors as well. Maybe the entirety of the parking lot is gravel and the landowner has decided to use the grid pavers for the accessible parking space and the access aisle adjacent to it, which is perfectly fine. But yet again, in terms of the opening on the surface can't be greater than a half of an inch. So the surface really needs to be maintained and infilled with that dust or whatever the planned infill surface might be. It needs to be maintained. Otherwise, that opening is going to create a non-compliant surface. Wood boards over time, those are going to start to rot and decay. They'll need to be removed. So that's another thing that you're going to be thinking about in terms of maintenance, about what is our schedule for reboarding sections of our bridges or walkways across our trails. And then other issues that might create openings or changes in level in your accessible route. This could include the storm grates, where this storm grate, the way that it's been placed and the design that has been used, it has an opening greater than a half of an inch. That definitely needs to be changed out. What I probably would have done here is move that bench forward of the storm grate so it was an area that you couldn't actually walk back there, and you would have still had the bench on a level surface. And then some of you might be familiar with the Vietnam War Memorial. This is kind of an interesting case study where the whole premise of the design of the Vietnam War Memorial was how it's located on the National Mall, that you would look across the grass, and you would only see the wall, the magnificent of the black stone memorial. The designers did not want you to be able to see the accessible route or the walkway alongside of the more memorial. So the planning team had people with disabilities involved, and somebody had the idea, well, why don't we use these pavers that the way that they're separated on installation, they're meant for grass to grow up in between them. And so as you looked across, they thought that that would accomplish their goal, looking across the mall and not really being able to see the path itself. Well, as it turns out, the way that they were installed, the openings were much greater than a half of an inch. And before the ribbon was even cut, before there was the opening ceremony with all of the dignitaries, the National Park Service had an accessibility complaint about the use of the pavers. And so down literally at all hours of the day and night, working up to the evening or the day of that grand ceremony with all of the dignitaries, the contractors were pulling up the main section of the walkway and putting in a unitary slabs of stone in order to provide the accessible route to or through the memorial area. And so something, if you're in Washington, you might want to check out how they ended up doing that. Loose fill at playgrounds. This is one where if the surface has not been installed properly and maintained, we'll see these moguls or these hills and valleys within the accessible route to each piece of accessible play component. The surface is no longer firm and stable, but there's a lot of kick out areas and a lot of ruts and valleys. So definitely something to think about. And then the lack of the level clear floor or ground space for each play component. And so again, this is that kick out area. And so this was part of the Access Board funded study that we did on the accessible surfaces for play areas back between 2008 and 2013. And so one of the things that we found about this surface, or the use of the engineered wood fiber, was that there was a huge disparity between the lack of information the playground owner would need about installation and maintenance versus what is given out by the manufacturer. So as a result of us publishing our first year findings, IPMA, the International Playground Equipment Manufacturers Association, ended up writing and publishing a position paper on how to properly install engineered wood fiber so that it can be considered a firm and stable accessible surface. And basically they said that you needed to do that in layers, in 4 to 6 inch layers where it's watered and compacted, another layer watered and compacted. And that it really means that your installation has to be proper to start with in order for it to be maintained over time. So you might have heard way back when, 15, 20 years ago, it was very popular for a sales associate to tell you, oh, just, throw it in the playground, shovel it in, blow it in, and it'll settle over time and it'll be fine. That's not the case at all. It really needs to be put in layers, watered and compacted at each layer. And then other types of surfaces that might not be considered firm and stable. Definitively, we know from case law that sand is not considered a firm and stable surface. We also know that particle size affects the usability of the surface. On the far left side, those first two pictures, you would have large stone surface. We definitely know from case law that gravel is not considered an accessible surface. We also know from case law that center photo with the blue tennis shoes that pea gravel is not an accessible surface. And then on the farther end, the right-hand side, that's that crushed limestone, something that has been compacted with a smaller particle size, sets up with a much greater likelihood of being firm and stable than the other two surfaces. And then we also know from case law that grass on any given day may or may not be firm and stable. So you cannot solely rely on grass as part of your accessible route. So some design and installation considerations is that the Access Board back in 2011 contracted a report that was done by the Ballast Architectural Research Consulting. And the report is on dimensional tolerances in construction for surface accessibility. It's on the Access Board website. I've given the link here. It's an excellent report, especially for those of you that are working with the designers and especially those of you that are putting together the bid specifications for the design of the path system and the installation of the surface material. And so they talk about what should be communicated in those documents, like what you want, the standards that are being used, how you'll verify compliance with the standards, and what the results for non-compliance will be. And so they talk about using the drawing dimension that is less than a maximum limit of more than one. So they talk about the regulatory requirement, and instead of designing to the maximum allowable in the technical provision for the slope, the running slope, the cross slope, designing for the construction tolerance instead. So if the technical provision, the maximum running slope is 5%, you should actually be designing to 4% to give you that tolerance on site. Same type of thing with the cross slope. Instead of designing to 2.08%, you should be designing to 1.5%. And so, we had been advocating this with the National Park Service for years. Back in the late 1990s, we had been advocating for the Park Service to kind of adopt this tolerance into their design practice. And then the Bayless report was published in 2011, and it kind of took it one step farther. And so that again is how this chart tries to relay how to design the standard or to design to a higher standard than the accessibility standards. So, 1 in 20 or 5%, you're designing to 1 in 25, or what is 4%. If you're using a ramp, instead of designing to the 1 in 12 or what is 8.33%, that you're designing to 1 in 13, or what is roughly 7.5%. And again, the cross slope, instead of designing it to 2%, you're designing to 1.5%. So, and then, another case study here to make this point with you is that talk about an engineering feat here. This is an example at the scenic viewing area for the Pat Tillman Bridge that goes across the Hoover Dam. I have to explain to my 20-year-old, the Pat Tillman Bridge did not always exist. The Hoover Dam was a construction wonder in and of itself. The building of this bridge was as well. And so the Bureau of Reclamation recognize that scenic overlook on the bridge gives a unique view to the Hoover Dam that visitors wouldn't normally have seen. So they wanted a rest area that people could get out of their car, and tried to figure out how are they going to get people up this significant change of elevation. So they came up with this switchback ramp system, but decided instead of building the switchbacks as a ramp at 8%, they would build the entirety of the switchbacks at less than 5%. And they did that. And how do I know that? Because my team measured every single segment of that switchback, and it was all less than 5%. And then down along the left-hand side of it, there's a series of stairs. So if you have that 12-year-old or 15-year-old that they've seen enough and they want to get back to the car, They can take the quick route down the stairs, while the rest of your party might choose to take the meandering or accessible switchback. But if you have the chance to visit it, I would highly recommend it. The Bureau of Reclamation did an awesome job on that project. So building into your specifications, the construction tolerances, and this again goes back to the ballast report. Define your measuring tools. I mentioned this last time that when we're looking at accessibility, we're using a 2-foot level, a 24-inch level, because that is what most closely replicates the footprint of a wheelchair, either a manual or an electric wheelchair. We don't want to be using a 6-foot level or a 10-foot level because you're not going to get all the little dips in the middle of that tread. And then defining in your bid package what the remedial actions are that would be considered acceptable, and defining that that's at the cost of the contractor to make those corrective actions. If you're doing a post-construction inspection before you accept the project, as you should be, if you find parts that are not compliant, that it is to be remediated at the cost to the contractor. So in my measurement tools, we do not want to be using a laser transit. A laser transit you would be putting at the top and bottom of the run, and you're going to get an average of the running slope. That's not going to show you all the segments in between. And we want to know all the segments in between because a person with a mobility impairment is using all of the segments in between. So you can use that 2-foot level. And then the ballast report also talks about how you can use the 10-foot straight edge to find those little dips in between. And then that report as well talks about the measurement protocols, looking at the difference between those paths that might be either 6 foot, less than 6 foot wide, or more than 6 foot wide, and the increments to do those at. So, if it was 6 foot, if it's less than 6 foot wide, you're looking at 10-foot increment. And then if it was greater than 6 foot wide, you're looking at 10 foots along the 2 different paths or the outside of the 2 paths. So the difference between going down the center of the path versus going down the 2 sides of the path. And so again, I'm going to kind of go through these quickly in order to provide time for questions as well. But I highly recommend that, especially if you're one that puts the bid package together. So a couple other research studies that you might be interested in. The Access Board did a study about the usability of exterior surfaces and the roughness of those surfaces and how that vibration can impact a person using an assistive device. So there were a lot of issues that were identified along the way of that study. That's where the pavers can become such an issue. And so they have, out of that study, they recommended that there be some type of way to, which we still don't have, a way to determine the roughness of the surface itself. And then getting to, the core of the question that we've had for 40 plus years is, what is firm and stable? How do we define that? Tongue in cheek, you'll hear people use the quote unquote heel toe test, that you'll put your heel down initially to see how much it impacts into the surface, and then you move your toe back and forth to see how much the surface displaces, and that could show you what is firm and stable. But again, that's left to a person's own professional judgment. So we look to the case law. I've included a lot of different examples here, going back to that original Green Bay complaint against the city there, where the wood chips were not found to be accessible, and they were required to pull all those up and replace it with a unitary surface, all the way up to, the city of Weston. They installed some playgrounds that were sand. That was a private right of action by a parent, where the courts found that the city was in non-compliance with the use of sand and required them to pull out the sand at those two playgrounds and replace it with existing surfaces. And then probably the most current one that people are most familiar with is the Iowa City Community School District. This was a complaint in 2020 that the Department of Justice investigated and used that quote unquote heel toe method and determined that the engineered wood fiber, the way that it was installed and being maintained, was not firm and stable. And so through our research, we've really seen over, the last 30 plus years of the need for an objective way to measure what firm and stable is. And so in the early or the late 1990s, there was a rehabilitation engineering firm called Beneficial Designs that came up with a protocol for the ASTM 1951 test. That photo on the left shows the 1951 test. It's a lab controlled environment. It uses a manual wheelchair where the user rolls up a 7% ramp in order to get a baseline measurement of the workforce to go over the ramp. Then they move over to the sample surface and they roll across the sample surface. And if the amount of work to go across the sample surface is less than that 7% ramp baseline, the surface in the laboratory will meet the criteria for 1951. That equipment is very costly. It's very difficult to bring into the field. So what can we use in terms of our facility owners, operators, to have a more compact portable test to take that into the field to determine if our loose fill materials are firm and stable? And so that same company, Beneficial Designs, came up with this center device called the rotational penetrometer, or it's also referred to as an instrumented surface indenter. It is a wheelchair caster that is placed on a tripod with a spring-loaded caliper. And you initially place the spring load into the surface, and that initial reading gives you a measurement for firmness. And then you move the caster back and forth a series of times. The spring load continues to apply force into the surface, and it measures the further displacement into the surface. So that second reading is the stability for the surface. And so we've tested this, we've used this device in a multitude of different research studies and found that it's probably the best portable device at this point in time in order to measure or give an objective measurement for firmness and stability. So we started working with RESNA, the Rehabilitation Engineering and Assistive Technology Society for North America, to develop a standard test protocol for the use of this device. And so we're getting ready to publish our first section of the standard. RESNA is an ANSI approved standard, so it will be part of the ANSI standard family. And once it is available, it's something that you as an owner operator could adopt the test method in order, especially upon installation, and then again for maintenance, that you could use the device to determine if the surface was firm and stable. There's no pass-fail values associated with the device or the standard at this time. It's purely informational for you as the facility owner operator to determine what those values will be for your situation. So the device has been used in a variety of different research studies over the last 25 years. The Access Board had contracted or commissioned Beneficial Designs in 1999 to do a pilot study with human subjects, testing the objective measurements for firmness and stability over different surfaces. So that was one of the first times it was actually used in the outdoor environments. The Forest Service lab has used the device to test different binding surfaces for engineered wood fiber. And that was the way that they tested for the firmness and stability and issued their report for that. We also did an ASTM interlab study in 2009 where we got 7 different devices and 7 operators that had never used the device before. We brought them all together into a hotel ballroom and tested the device on across to 7 different surfaces. And that the purpose of that interlaboratory study was to show the repeatability and reproducibility of the device. And so we had a very good correlation of those two and showed that, it's relatively easy for somebody to learn how to use very quickly. We also used the device by the Access Board funded longitudinal study for playground surfaces, where we tested 9 different locations on the playground across 35 playgrounds in the Midwest, where we looked at the slope, the cross slopes, changes in level, openings, and then we also measured the firmness and stability with the device to look at how those different types of surfaces compared to one another. We did the same type of thing with a commission study by the Access Board again at Indiana University and the National Center on Accessibility on trail surfaces. And then back to that Iowa City Community School District DOJ complaint that was investigated. This was the device that we used to set up a testing protocol for the school district to determine what the firmness and the stability of each of those playgrounds were. So when the Department of Justice looked at the original complaint to investigate it, they decided they were not going to look at just the single playground. They told the school district, we want to see every single playground that you've installed since the 2010 standards took effect in 2012. And so that ended up being a dozen different locations. So we worked with an independent third party to use the same type of test protocol that was used in the playground study funded by the Access Board. And so the school district was able to use this data, and their primary concern was that the majority of their playgrounds were surfaced with engineered wood fiber. And their concern was that the Department of Justice was going to come back and say, you need to pull out all your engineered wood fiber and replace it with a unitary surface, which they had more than 60 playgrounds. There's no way that they could afford to do that. And so through the use of the device and the testing protocol, the grounds crew was able to use the data to adopt a maintenance routine to compact the surface material much more efficiently. So in the first 2 years of testing, they went from like barely an 80% pass rate on the values that they had adopted to more than a 98% pass rate by the end of the second year, because they were able to adopt this compacting protocol where they compacted the surface in 3 different directions. They had it installed and layered, watered, compacted, and they went in the 3 different directions and had a much greater success rate based on the data that they were able to collect. So just some examples of how the surface indenter collects that information and the different values. If you were to test it on concrete, that initial reading would be about 1/10 of an inch or less than 2/10 of an inch. And then if you move the caster back and forth for stability, it barely goes up. But if you were to do that same thing on sand, that initial reading is going to be well over an inch on firmness. If you continue to move the caster back and forth to measure for stability, it's going to be well over more than an inch for stability. So we at RESNA are continuing our work on this standard development. Our second section of the standard is going to be on when, where, and why, or basically it's a guide for making measurements for firmness and stability. how you could do that on the trail or where you could do it on the picnic area or along the beach access route or in the play area at the dog park and so forth. So we're working on that. And then we're working on looking at or exploring a test method to measure for slip resistance. And so those meetings are open to the public. If you have interest in it, you're more than welcome to attend. You can send me an email and I'm happy to forward the information along to you if you have interest. But at this time, I've done a lot of talking, so I will open it up to those of you that might have questions.
Jennifer, Bruce did have a number of questions here. And Bruce, do you want to ask them yourself or do you want us to just read them to Jennifer? Which is the best way to deal with this?
Thanks. Great information, Jennifer. Thank you very much. I've been doing mostly focused on playground design, but also trail design for probably 40 years, maybe a little bit more. Um, and I don't want to sound too cynical, but we've gone light years beyond what I in the chat wrote. I grew up with a 3-story metal rocket out in the middle of a dirt field. Was kind of the standard, and I know we've gone way beyond that, but I just am concerned that when I look around at what the world is doing in terms of play environments for everyone, and I'm talking about the temporarily able-bodied all the way through people with challenges and so on and so forth. But the United States is one of the most difficult places to design what I would call really creative play, as opposed to places in Asia or Europe or whatever. And I just have a concern that still meeting the safety standards and making sure everybody can access and all of those things. I'm not discounting that, but um, I know it's a fine line between how much of this is avoiding litigation and how much of it is really applying good standards for good practice.
Well, sometimes good standards evolve out of good litigation. I just made that up, so I don't over quote me on that. Unfortunately, we are in the United States one of the more litigious when it comes to the design, construction, and maintenance of playgrounds. And surfaces has the biggest influence on whether or not a person, whether or not they have a disability, can use the environment successfully. And so when it comes to the development of the standards, it's really looking at how can you create the safety standard for impact attenuation that is complementary to the accessibility standard for people in order to them to have the equal opportunity to participate and use the playground itself. So it used to be, if you asked me this question 25 years ago, I would tell you that safety and accessibility on the playground were still bumping heads. But at this point in time, with the way that technology has evolved and how many new different types of surfaces that we're seeing on the playground, I think that they're much more complementary to each other than they ever have been. But our main point is we need to have a way to, we have a way to measure for impact attenuation, but we don't have a way to measure for firmness and stability in the field. And we're hoping that this test method is what will get us there.
You know what? It's really great, and I'll close with this and leave it to others. But even most recently, taking everything that you're talking about and just asking the people that are using it, outside of all this testing and everything, but we're really challenged with the engineered wood fiber right now. I'm finishing up 3 playgrounds where we're using that material, and I'm learning that people in wheelchairs don't view that as ADA. So really getting to the user group and saying, what is the best surface for you for the playgrounds that I'm designing is really kind of bedrock at this point.
Yeah, I mean, I think that it's a perception issue is that, and this really comes from leading the Access Board funded study on the playground surfaces, is that I learned through that study is that if the engineered wood fiber is properly installed and maintained, it absolutely positively can be maintained as an accessible surface. And there are a lot of entities that don't have the money available for a poured-in-place rubber or a synthetic turf type surface. But I will also tell you, over time, those unitary surfaces may not meet the requirements for impact attenuation. So as much as you might get feedback from user groups that they don't like engineered wood fiber, that they want something fancy like the synthetic turf or the poured-in-place rubber, you're not going to get the 20 or 25 years out of that type of surface unless you specify in the bid package that it impact attenuation values that are 20% less than the maximum allowable right now. So you have to build in that tolerance if you want to use a higher end surface.
Thanks for your work and thank you for this forum.
Thank you.
Really appreciate it.
Jennifer, if I could jump in real quick, something we see in the field a lot and thinking about if any of our participants or agencies were to take a playground that had an engineered wood fiber surface, when we look at those, they're usually bound in, they're hemmed in some way with some sort of timber structure on the outside or some sort of wall, sometimes plastic barriers of some kind. If they were to change that surface and take it out and reinstall it correctly, how do you recommend they get over those barriers? What are some creative ways or some good ways to make sure that the people coming from a parking lot can even get into an accessible surface as a remodel?
Right, that's a great question. So they need to have the accessible route that connects the site arrival point to the entry of the playground. And so where we see that the surface has been applied above grade and it hasn't been like excavated for a subgrade, that's where we see the majority of issues, where they're using maybe that plastic timber border with a plastic molded ramp. And over time, what we've found in our accessibility assessments is that those ramps get so hot that they end up melting or warping, and so they're no longer compliant. And so, if there is anything that you could do, one, I would highly recommend that you do a site survey to figure out what the actual topographic elevation of your site is in order to do some excavation for proper drainage. You absolutely have to have proper drainage, which is usually a stone base, to follow the manufacturer's recommendation for the drainage system. And if you could use that primary route, like the concrete or asphalt path that's connecting from the site into the surface, to kind of do a zero depth entry or something at less or a blended transition at less than 5%. That's what we've found to be most effective. And then you could build or replenish the engineered wood fiber so they kind of like meet on top of each other.
One area that we run into fairly often is a remote access route going to some fantastic features in a large facility. And currently that surface on that route is grass or some sort of vegetated surface. It's just been that way forever. Is there any situation where maybe it's not grass? Is there another vegetative surface or a certain way of compacting and designing it where you could have a natural surface? Other than you talked about the loose gravel fill, but I'm wondering about vegetative specifically. Is there any kind where you've seen that can work?
Yeah, I mean, we have a lot of nature preserves that their trail is just like mowed grass. And, so that's the issue, is that after a week of rain, it's not going to probably be a firm and stable surface. But in the middle of August, when we've gone 5 weeks without rain, it's probably nice and hard for the firm and stable surfaces. That it's just so unpredictable. So that would be one that I would look at, like what the programmatic experience, like what's the purpose of the trail? What am I meant to see in this path system? Is it something that you could use a soil stabilization product on, perhaps? Or if it's something that maybe you have summer camps coming out and they're trudging through the forest and really wearing out the path, that the least little bit of rain is going to make that path really muddy. That might be something that you're using the temporary surfacing over, that could be a little bit more cost effective until you get to the point that you decide what is going to be the primary surface that we're going to use or we're going to permanently install here. So that was my way, Joe, of not answering your question.
Thank you. I was going to ask a follow-up on that. Awesome.
And I think there's a lot of different opportunities in the outdoors that you don't have to have a trail that's all the same surface. You could have, the different types of surface on different segments of the trail. It gives to the aesthetic of, what the experience is. Maybe you have a boardwalk, that goes across the marsh area. Maybe you have a soil stabilization product that goes into the wooded area. We had a trail in the South Bend area that they wanted to use the crushed limestone, and the designer had really good experience with the crushed limestone. And the crushed limestone is all of the secondary trails that go through the Notre Dame campus. So they had had a really good experience with the crushed limestone, but the way that the location and a segment of the trail that was installed in the park, they had, like a flash flood come through, 100-year type flash flood, wash the whole thing out. They replenished the whole thing, but it continued to be susceptible to rain. And it was part of the area where maintenance staff were driving their truck. So their truck was then putting additional ruts through the crushed limestone. And finally, they just said on this segment, we're going to pull it out and we're going to just put concrete on this segment. And the whole rest of it will continue to maintain as the crushed limestone. So, it doesn't mean that you have to commit one way or another to one singular surface. Well, I'll add my contact information up here. If questions come up, you're more than welcome to reach out, send me an email, give me a call anytime. I'm more than happy to take those questions as they come up.
Great. Thank you, Jennifer.
Thank you, Jennifer. And just want to say that we really appreciate everyone who is able to join us. Spread the word. This will be will be published as a video onto our accessibility page on the GMR PTC website as soon as I'm able to get that edited down and available. And hopefully for the next one, which will be coming up in September, we'll pick out a topic, but you can certainly let us know what you would like to see for a topic as well, because we'd love to hear what your needs are. And hopefully that can be helpful to us and make sure we're meeting your needs. So thank you, Jennifer. Thanks, Renee. Appreciate everybody coming out.